All right, so there's just a few problems I want to go over with you guys. So the first ones that we're going to go through, it says express in simplest form and with a prime number base. All right, so all of these problems that we have here, we don't want to leave 9, 4, and 25 because they're not prime numbers. Remember, prime numbers is a number whose only two whole factor numbers are 1 in itself. So the only factors that are whole numbers that can go into the number is 1 in itself. And 9, 4, and 25 are not prime numbers. All right, so we want to simplify these. So just like everything in math, 2 over 4 is equal to 1/2. You would never leave it as 2 over 4 because that's not simplified. You want to rewrite it as 1/2 in its simplest form. So we want to do this with these as well. So the first thing that we'll do is we'll take that base. Since 9 is not a prime number, we want to take the base 9, and we want to look and see, well, can we rewrite 9 as a smaller number, whole number, raised to a power? Because if we can, then we can simplify that even more. And we know that the two factors of 9 are 3 and 3, so we can rewrite that then as 3 squared. So wherever we see that 9, we can replace it or substitute it with 3 squared because they're equal to the same thing. So we can rewrite this in as 3 squared raised to the 4th power. So 9 raised to the 4th power or 3 squared raised to the 4th power are both the same thing. So then our rules, our index laws that we learn, our power to a power, we will multiply. So that then gives me 3 to the 8th power. All right, so that's all that we need to do for that one. It just says write it in simplest form with a prime number base. All right, so we don't want to actually evaluate what 3 to the 8th power is because we want to leave it with a prime number base. All right, so then for B, if we look at the two numbers that we have here, 4 and 2 raised to the p power, well, we know that 2 to the p power, it's already written as a prime number base. So there's nothing that we're going to do with that one. So same thing as we did with the 9, we'll look at the 4 and say, what factors do we have, or can we rewrite 4 as some number raised to a power? And we're looking specifically for that to be a prime number. Also, since this number here is a 2, and there's nothing that we can do with it, the only way that we will be able to simplify these or to combine these is if this 4 can be re-raised as 2 to a power as well. So if you weren't sure, you can use that as a way to help you try and guess at what numbers you should be using. So 2 times 2 is equal to 2 squared. So we know that wherever I see that 4, I can rewrite it as 2 squared. So I can rewrite this in as 2 squared. So remember, 4 is equal to 2 squared. So now since our two bases are exactly the same, these are both 2, and they're prime numbers, we can then add these together because when we multiply with like bases, we add, so it becomes 2 raised to the 2 plus p power. Right? That is it in simplest form. It's prime number base. There's nothing else that we can do with it. All right, the third one, same thing as we did before. This 2 to the p power, we can't reduce that to it all. Well, this 3 to the x, there's nothing that we can do to that 3. Right, that is a prime number. It's the smallest number. There's no other number that can go into it. So that's it. It's just 3 to the x power. The 9 raised to the y power, as we know over here, we know that 9 can be rewritten as 3 squared. We can then go ahead and rewrite 9 as 3 squared, and it's being raised to the y power. All right, so then the first thing that we're going to do is we're going to use our power to a power rule. So then we get 3 to the x power over top of, we will multiply these two, so it becomes 3 to the 2y. All right, now since we have the same base, 3 and 3, we can go ahead and simplify this even more. And we can do, since we are dividing like bases, we would subtract, so it becomes 3 to the x minus 2y power. And that would be your final answer. All right, it's in simplest form, prime numbers, there's nothing else that we can do with it. All right, then the last one that we're going to do is this D. So we have 25 raised to the x minus 1 power. So same thing. We need to see, can we rewrite 25 as a number raised to a power? And since I know that 5 and 5 both multiply and give me 25, I can rewrite that as 5 squared. These are the exact same. They represent the same number. So where I see 25, I can go ahead and substitute 5 squared in for it. It's not changing this at all, this value at all. 25 is 5 squared. All right, now here we do have a power to a power, but we have both the x and the minus 1. So just make sure that when you're multiplying this, that you're multiplying the 2 into both of them. So then it becomes 5 raised to the 2x minus 2. All All right, and that would be your final answer. There's nothing else that you can do with that. We have a prime number base, we simplified it, and that would be all. Now there's just one more set of problems that we're going to do. So the directions for this would say remove the brackets of, and may say simplify, but remove the brackets of or simplify, they're meaning the same thing here. So one thing I want to point out to you is this first problem A says 2 to the x raised to the third power. That is different than 2 to the x raised to the third power or 2 to the xy raised to the third power. Whenever we have the parentheses, whatever is written in the parentheses, everything in that will be getting raised to the third power. Here, since it's not in parentheses, the 2 is not being raised to the third power and only the x is. Here, once again, the 2 is outside, so that would not be getting raised to the third power, but only the x and the y. All right, so it's important for you to understand with the parentheses that if it's inside the parentheses and being raised to the power, everything is being raised to that power. And if it's outside the parentheses, that will not be getting raised to the power. So for here, we can rewrite this 2 as 2 to the first power times x to the first power. Whenever we don't have a power there, it's understood to be 1. And now we know that both this 1 and this x, this 1 and this 1 for the x, both need to be raised to the power 3 because they're both being raised at third power. Our rule with power to a power is we multiply, so then it becomes 2 cubed times x to the third power. And since we know what 2 cubed is, we will simplify it and we will rewrite it as 8 to the x to the third power. All right, same thing for this here. We know that this can be rewritten as 3 to the first power 3 to the first power times c to the first power over top of b to the first power. And once again, all of this, since it's in the parentheses, is being raised to that fourth power. So our rule is power to a power, we multiply. So we will go ahead and this will become, I'll rewrite it step by step. So this becomes 3 to the first power raised to the fourth power times c to the first power raised to the fourth power over top of b to the first power raised to the fourth power. So all these we multiply, so it then becomes 3 to the fourth power c to the fourth power over b to the fourth power. If we want to do mental math, 3 to the fourth power, we can rewrite this as 3 squared times 3 squared. And I chose that because you should all know what 3 squared is, and that will then give me 9. So 9 times 9 will then give me 81. So the final answer for this is 81 c to the fourth power d to the fourth power. All right, there's nothing else that we can do, and that is it. All right, so that is it for this video.